Welcome back. Recorded to you live from, well, recorded live, redundant, in my office. What we're going to look at is rules for probability. So just remember here we've got two rules. We got the multiplication rule and we have the addition rule. The multiplication rule is this: the probability of A and B is equal to the probability of A times the probability of, well, in this case, if we know that A just happened, so then it's the probability of B given A. And little side note here on that is that if A and B are independent, then it is just the probability of A times the probability of B. Because independence means that knowing one thing does not change the likelihood of something else. Once again, you should know this and should be able to just state this verbatim whenever asked. How do you know something's independent? If knowing one event, in this case, if knowing A does not change the likelihood of B happening, that means A and B are independent. So then it would just be the probability of B because knowing A doesn't make a difference. All right. We don't always know that that's true, so we can't just assume that they're independent. So we usually go with this formula just to be safe. And then if we find out that it's B is just the probability of B not knowing, so then we go independence. All right. The addition rule is probability of A or B. And you're going to hear me say the words up here is and when we're talking about intersection, and this is or when we're talking about the union. Probability of A or B is equal to the probability of A plus the probability of B. And now when we've done these using a table, you remember that we've counted now something that happens in some cases twice. So where they both happen, we have to get rid of that once. So we have to subtract the probability of A and B. And remember, if they're independent, then this I can use this equation. All right. If not, then I'm always going to use the top equation. If I don't know, then I'm going to use that equation. Now, what happens if A and B are disjoint? What happens if they are mutually exclusive? I'm trying to move my screen up here. All right, just ignore it. If they're mutually exclusive, then this probability is 0 because there is no intersection. All right. So if A and B are mutually exclusive, there is no intersection. All right. And then we have the conditional probability rule, which is this: probability of A given B is equal to the probability of A and B all over the probability of B. So let's take a look at what that would actually look like in a problem. So let's look at this first. All right. When we look at that information first, and let's zoom in on this here a bit. When we look at this information, it says about 27% of adult internet users are 18 to 29 years old. Another 45% are 30 to 49, and the remaining 28% are 50 and over. The Pew Internet and American Life Project finds that 70% of internet users aged 18 to 29 have visited a video sharing site, along with 51% of those 30 to 49 and 26% of those 15 and older. So the first thing I'm going to do is I'm going to create this into a tree diagram to represent all of this information. So my recommendation is write this information down quick and then pause, I should say, write it down quick, then hit play and see what this looks like in terms of a tree diagram. So here is the tree diagram of the information provided. It said that of those that were, and I'll just clear this up here, this is an 18 to 29 years old, was 27%. So that's this 27% over here. All right, and then I've got the corresponding 45% for those that are 30 to 49 and 28% for those that are 50 plus. Then it said, of those that are 18 to 29, so of those that are 18 to 29, so only looking at that, 70% are video streaming users. All right, that means then this requires you to remember here a little bit that means 30% of those are not. So these should add to 1 or 100%. So down here, of the 30 to 49 years olds, 51% are video watchers and 49% are not video streaming users. They're not YouTube users is what we're talking about. All right, so then those that are 50 plus, 26% are, and that leaves us with 74% who are not. All right, then if we look at this right here, this row, if we take 0.27 times 0.7, we can find that numeric answer that you put into the reflection response. But what is this actually finding for us? It's finding the probability of, what was 0.27? 0.27 is the probability that they're between 18 and 29. They're multiplying that, so that's and. The probability of video given they're 18 to 29, excuse me. All right, so what this is actually giving us is the probability of A and B, where A is their age group and B is whether or not they're a video stream user. So here we are given the probability that they are 18 to 29 times the probability of V complement. Remember, that's what the C up here stands for. Complement means not video watchers. So they either are a video watcher or they're not a video watcher. And to find that, I would take 0.27 times 0.3. Now, careful here. This line right here looks like a fraction bar. It's not. That was just where I was putting my answer to my question. All right, so let's go back and take a look at some of the questions I was going to ask you to find. All right. Find the probability that an adult 30 to 49 did not visit a video sharing site. So what I want you to do there is I want you to, it's just like we did in the previous line up there, so go back if you have to. In your reflection response, you're also going to put this. So first you're going to put the answer to the first one, which was the multiplication. Then you're going to write down notation, correct notation, and the middle, what actually things you're multiplying by, and then third, your answer. So you say the probability of this times the probability of that equals number times number equals then your final answer. So put that in the reflection response. We're going to go on and we're going to do this. Find the probability that a person selected at random visited a video sharing device. That should say service. All right, so find the probability that a person selected at random visited a video sharing service. In other words, what percent of adults visited a video sharing site? So to do that, I am looking at, and I'll choose a third color, and yes, it's going to get sloppy because that's what I do. I need to find out so they're either here, or here, or here. So the probability that they visited a video sharing site, it happens either here, we'll call this X, here, Y, here, Z. So it's going to be X or Y or Z. And you might say, boy, you're sure emphasizing that word or, Mr. Stefan, and I am for a reason. Because you can't be in X and in Y and in Z at the same time. You can't be 18 to 29 and be 30 to 49. They are disjoint. They are separate events. They are completely segregated out. So they're disjoint. They're mutually exclusive. They have nothing in common, which is why I use the word or, because it's the addition rule. So I want to find the probability of X or Y or Z. All right, we already found the probability of X, which was these two values multiplied. In the reflection response, you found, I'm kind of giving it away, those two multiplied. And then for the third one, you would say it's these two multiplied. You get all three of those answers and add them up, and that would be the likelihood that someone selected at random, probability that someone selected at random, an adult, used a video streaming site. All right, we're going to do one of the upcoming topics that I'll talk about, probably do it in class, and maybe if you write all this down, I'll even use this as an example. We'll be talking about a different rule called Bayes' rule. It's technically not an AP Stats topic. However, once we get this far in the process of what we're doing, you can figure it out without even knowing the formula for it. And we can do that in class very quickly and simply using this example. So you have something to fill out for reflection response. Go back, remember we did the multiplication rule, the addition rule, and the conditional probability rule. I'm going to do one more conditional probability quick. Conditional probability is probability of A given B is equal to the probability of A and B divided by the probability of B. A survey in 2000 suggested that 85% of college students had a Facebook account, 54% had a MySpace account, and 42% have both. If a college student is selected at random and we learn that the student has a Facebook account, what is the probability that he uses MySpace as well? So what I'm going to do is I'm going to go, and again, you might want to just pause, jot this information down, and then hit play again to see how this translates into what I'm going to write down and how I'm going to solve this problem. Okay? Probability of both. Both needs to be interpreted as an actual probability statement. So when you say both, what am I talking about? We're talking about they have Facebook, and then this is key. This is why we use language so much in terms of interpreting. It's Facebook and MySpace. All right. The likelihood they have Facebook and MySpace was given as 42%. The question then asks, if a college student is selected at random and we learn that the student has Facebook, so the student has a Facebook account, that's the same as saying, hey, we know this information. We know that this kid has Facebook. That means that's a given statement. So when we're doing the problem, interpreting the question, realizing, oh, they're saying, when we're doing this, given they have Facebook, what's the probability that that person has a MySpace? All right, to use the formula, which I recommend you do directly, I'd go formula of M and F over probability of F. Straight from up here with what the formula says. So MySpace and Facebook, is that the same as Facebook and MySpace? The answer is, well, yeah, it's the same thing. You're just reversing the order. It doesn't really matter. So that we were given that that's 0.42 divided by the likelihood the person has Facebook. And we said that's 0.85. All right. So then we get this and we find out that it's roughly a half, roughly a 50%. So if you know the person has Facebook, there's roughly a 50% chance that they also have MySpace. So if they have Facebook, given that they have Facebook, of the 85% of the people who have Facebook, 42% have both. So there's about a 50% chance of selecting someone of the Facebook users who also have a MySpace. So again, we've reframed it out of only the Facebook users. And that's using conditional probability. That's quite a bit to give you right now. You know what to fill out for reflection response. There are a couple things in there. Go back if you have to. We'll see you in class.